Hello, my name's Jonathan Hankins, and today I'm going to talk to you about open source. As you can see, I couldn't get to Berlin because I've got a problem with the car, but neither could any of the others anyway, so it's no problem. I'm well prepared. As you can see, I've got cardboard and a Sharpie. I'm going to talk about how I'm going to get the car repaired, or how I'm going to repair the car myself, following an open source path. So when I get home, I'm going to have a look on the Skoda forum, because it's a Skoda, and you know, Skoda owners love their cars, and so there's a Skoda forum full of all of this free information about what you need to do to modify your car, or to fix the car if it breaks down. So what I'd like you to do is send your questions in. The boss is looking after that, so keep her busy. Questions about open source, not about Skodas though. So what do we mean by open source? So within the broader picture of open science, we can see open source as part of an open process. We can also think of it though in relation to fixing the car. You know, it's open knowledge, really. It's open knowledge. So it's often used for software, or operating systems, or research tools, or databases. So what do we mean then by open source? So firstly, source. When we're talking about computers, for source, it refers to the source code. And that's the machinery that makes the computer run. The ones and the zeros, I presume. It's the machinery. And open means that you can get access to it. So you can not only can you see it or read it and use it, but you can also modify it. And then you can let other people, or other people can use your modifications. So the thing about the fact that it's open and modifiable means that you can use it as you will. You know, it's not that you have to buy a package of something and then try and adapt it to your own, or try and adapt your own process to the package. You can actually adapt the program to your needs. So. And we all use it, you know. We don't all know this, but we all use things that are open source. So, for example, Android, that many of us have on our telephones, the poorer ones, that's open source. And WordPress is open source, that we use for blogging, and Linux for computers, which is what I'm going to talk about. But also cars. You know, this car has a Linux system inside it, and various networking systems. So, I'm going to go to the Skoda forum in a minute, but I'm going to use this computer that I've got. I can't show it to you. It's here, because obviously I'm using it for the camera. But it's an old computer. I bought it about 8 or 9 years ago. It was €200. It's a cheap computer, and it was great at first. I mean, it looked great. Came out of the box, looked fantastic. It's got one of these, or it had one of these typical, you know, American large, world-renowned operating systems on it that they all come with. And after a few months, it started to slow down, like they all do, underpowered computers. After about a year, I couldn't even use it anymore. So I had a look around, started to look around for open source systems, an open source operating system. People told me that you can put them on your old computer. So anyway, I came across something called Ubuntu. It's a Linux distribution. We mentioned Linux before for computers. So it's a Linux open source. It's a lightweight. That's what it is. It's called Ubuntu, and L means lightweight. And Ubuntu is heavyweight, and Lubuntu is lightweight. It's a lightweight Linux distribution, and it's really designed for people like me with old computers that can't use them anymore, with all of this system that's you know, all singing and all dancing and very heavy and requires you to buy a new computer every 5 years. So it's got a good, it's there for a good reason. It's designed and developed to help people like me not have to throw my computer away. Anyway, so I installed this open source operating system called Ubuntu. It's a skeleton system, so it just runs the computer, and then what you do is you can add all kinds of different things to it. So it's a lightweight framework, and then you choose the programs. So if you, like me, so you write a lot, so you need something that looks like Office or Word, you can get something called an Office suite from another open source developer. So one of the most famous ones is called Apache. An Apache Office suite, it's just like the other one, the big American one, and it's compatible with everything. And this is the big thing about open source, right? All of the stuff that is produced open source, they're like a big gang, these open source crew, and they're making everything compatible. So you can put Apache with Ubuntu or with any of the others. You can also, I mean, we're using Zoom, but there's an open source version of something that could be like Zoom called Jitsi, an alternative. So we could be using that. So it's all standardised so that you can fit it all and mix and match to what you require, which gives you obviously flexibility. So your operating system will go, which is developed by one group, will fit with your Word system, which was developed by another group, and your search engine, Firefox, which is Mozilla, that will also fit in it. And you can build yourself an ad hoc but self-designed beautiful system. And one thing that I should add, because I've done all this, is it was free. It didn't cost me anything. So, and this is typical with open source. Not all open source is free, but a lot of it is. And typically, as is the case with Mozilla, the developers are all over the place. They're geographically distributed. Lots of individuals from all over the place. And because the users can also adapt it and change the code, it's constantly being updated by the users, not only the developers. So this brings all kinds of advantages, right? So it's independent from single businesses, so there's not one person that can suddenly decide to stop it or to update it or to change it. It's a group. It's a group of people. And all of these people have got different approaches. They've got different ideas about why they're doing this. They've got a wide range of technical abilities and capabilities and ideas and aims and philosophies. All of this information, because they're distributed across the world, has to be shared. And so it has to be openly shared so that everybody can access it. And that, just by nature, makes it a transparent process. Everything's shared, you can see everything. So these are some of the advantages of it. It's adaptable. I mentioned standardization before, and that's really fundamental with open source, but we'll come back to that later. It's innovative, it's in constant development, it's low cost, much of it's free. People dedicate their free time to this. It's secure as well. The people who are developing this are using it themselves, and so there's a lot of peer scrutiny to everything that goes on, and so they're sharing the problems, they're sharing the solutions, and they're sharing them because they themselves use this stuff. It's not profit driven. Mozilla, who do Firefox, don't collect any search information or sell your data because they don't need to make, or they don't want to make, enormous amounts of profit. They're all the advantages. I'm not going to say that there aren't any disadvantages, because there are some disadvantages. It doesn't always work perfectly smoothly, but there are loads of advantages. And when it doesn't work smoothly, there's a forum. And so you write your question into the forum, and all of these people, they're just like the Skoda owners. They love their open source software that they've been working on and developing. And so they will help you to modify it, to get it to work as you want. Just really very similar to the Skoda idea. Skoda are the Skoda forums more about experience, and this is also about technical ability, but it's a sharing of knowledge. So my interpretation of open source is that it's not just about source code or technique or technology, it's about the knowledge and the ability to use the knowledge freely and openly. So it's also well used in many other fields, right? So we've got science, so open science. So here is, hope you've got a pen, here is openplant.org. At openplant.org, this is an initiative that promotes interdisciplinary exchange. Okay, so it's synthetic biology. It's about synthetic biology. It promotes interdisciplinary exchange, open technologies, and responsible innovation for the improvement of sustainable agriculture and conservation. So responsible in terms of that it has what people would think of as a socially advantageous goal, right? So it's aiming to improve the state of the world as its aim. And this is really, this occurs throughout open source. They're doing something with an aim to make things better in some way. So back to openplant.org. The initiative promotes, what they are doing. The initiative is developing new tools and methods for plant synthetic biology. So they want to develop tools that can be shared and approaches that can be shared. Standardised tools and standardised approaches that can be shared across the world, and so that all of the work can be shared. So this brings us back to the standardisation. They want to provide mechanisms for the open sharing, because you need some infrastructure. You can standardise all your resources, but you need a methodology to share it. So they want to apply these tools and all of these methods to world-leading projects in trait development. So in the development of particular traits in plants. They're facilitating interdisciplinary exchange. They want all types of different scientists and all kinds of people, and not just people who are interested and involved in the process, but as broad a range of society as possible, following a responsible innovation path. So they do a lot of outreach, and they're doing international development. It's an interesting project. I've got another one for you though. This is the next place I'd like to go to. This is iGEM. iGEM is really interesting because they kind of play more with the idea of developing all of this open source. They're doing open source techniques and open source standardized plant parts and molecular biology techniques. So iGEM has 20,000 standardized genetic parts. And they've got standardised tools, a toolkit that you can use for doing your synthetic biology with their standardised parts. And because these parts are standardised and the tools are standardised, they can be used across the globe, like very much like the plant thing. And so what they do is they run a competition. So they run a competition, a synthetic biology competition. It's for undergraduate teams and teams from secondary schools. So they've got enough stuff there and enough machinery and capability and tools to let people who are really beginning in synthetic biology have a go and try and resolve some of the problems that they give them. So they give them a problem or a series of problems, a standardised toolkit, standardised parts, and they try and the competition is to try and resolve these problems. Then they have a final. It's in Boston, Massachusetts. It was anyway in the good old days, and they give a prize. It's really a very similar aim, just a different way of going about it to OpenPlant. They're interested in a common syntax for exchanging DNA parts for plants, for example, as well as common research tools, and open and shared digital tools. Because once you've got this far, so we have to picture all of this stuff that we've been talking about today as a long process. It's a science process. and in order to get towards the end, you need some shared digital tools as well. So all of these things that I'm sure you've been watching all afternoon, like me, they all can be seen together as all part of a process. So we might think of it, they're here with the back to the car's still sitting here. We might find more lab coats, fewer overalls, a lot less WD-40, but comparable systems with similar structures and goals from synthetic biology, but openness, open access to being able to do it, really, as are the people at the Skoda, in the Skoda group. It's access to being able to do it. Databases are a big open source area, offering open source access to open data and publications. But that's something that's going to come along in the next talk, so I won't go too much into that. The EU is promoting open science and open source projects. It's a fundamental issue in its funding. So why is this? Why would they be investing 500 billion euros or however much it is in open source and open science? And the reason is it looks advantageous to science. If you think about some of the big projects that have gone through open source and through open science that have been successful over recent years, it does seem to demonstrate that putting 2 million heads every day together to develop Ubuntu brings its advantages. I'd like to thank all at Berlin Science Week for letting me do my presentation. Thanks to everybody at ORION. So ORION is a European funded project. They've got a MOOC on open science that's really very interesting, well organised. I've followed it. It's good. They do a Train the Trainer course, so if you want to step up another level, you can do a Train the Trainer course which sets you up to train people into open science. At the end of the Train the Trainer course that I've just completed, the last thing that we do is to do this presentation in Berlin. So this is the end of the course. I can thoroughly recommend it. It was a fine course, and the MOOC, and it's all free. For more about me, if you want to know any more about me, you can type these 2 words into Firefox and you will find me. That's J. Hankins, or just Hankins, that's my name, and Bassetti, that's where I work. Keep the questions coming, and I have a disclaimer because there really is nothing wrong with the car. Thank you.